Hello and welcome. My name is Chris Alexiuk, and today I'm going to take you through a full demonstration of how to set up and then run and then deploy the end-to-end Bloom project. So in this tutorial, we're going to cover literally everything. That's starting from account creation all the way to deploying it on a NVIDIA instance in Hugging Face Spaces. So we'll just get right into it. First things first, if you head to the Notion page that contains the example projects, we can go ahead and click on the Bloom project. And there's going to be a little checklist here of things we can do. I've added this for clarity, so if people are just using the Notion page, they can ensure they have access to all the tools they need. So let's just head to Hugging Face. I mean, nothing better to do but type in Hugging Face to Google, click on the first link, and we're going to sign up. I'm going to use the email address I've set up for today, which is going to be generativeai.demo@gmail.com. And I'm going to kind of create a password. So we'll just create a very secure and safe password here. Click next. We don't need to save that. I'm going to fill out these forms. They're fairly self-explanatory. You can fill them up yourself. Our full username will be Generative AI Demo. Full name will be Chris Alexiuk. That's me. We don't need an avatar. We don't need to put GitHub. None of this stuff matters to us right now. I cut it where I read in full the terms of service and code of conduct. Once that's created, we're going to go ahead and confirm our Hugging Face account. So we navigate to our email, and we can just go ahead and confirm it. We've verified our email. Very happy about that. So now that we have our Hugging Face account set up, we're almost done. What we need to do is head to our profile. We're going to go to our settings. We're going to go to our access tokens, and we're going to create a new token. This token is going to be for the Generative AI demo. We do want read and write, which means that we will pick write. So we can generate a token now. I'm not going to show the token. I'm just going to copy and paste it into my clipboard. And that's that. So we've kind of done the Hugging Face setup part, most of it anyway. When it gets time to the GPU, we are going to need to set up billing, but we'll do that at that time that we reach that step. Let's head back to the Notion page and see what we need to do. So next up, if we're going to be using Premium Collab, we need to sign up for that. So even though we might not need Premium, I'm going to go ahead and show you the process of setting up for it, just so that you could have seen it. So let's click on the link here. You'll see here that we have this Collab subscription option, but we have compute units available to us through pay-as-you-go. So let's go ahead and click on that link. Now that we have access to this pay-as-you-go option, you can see that it costs $13.99, or about $14. This is in my local currency, which is Canadian. So your local currency might be a little bit different. For going onto the Pro subscription, we do get access to a little bit more. So if you're just going to use it for this one example, I would still recommend going with the Collab Pro option, as that's going to get you access to a little bit more bells and whistles, and you can always cancel once you're done. Just make sure that you remember to cancel. So I'm going to go ahead and click on that. Going to go ahead and agree. I've cut out the part where I read in full the Collab terms of services. All we have to do is add a payment method and click buy. So I'm going to do that off screen. Okay, so once we've made the purchase, we can go ahead and click on the I need Pro or Pro Plus for a specific project or class. Just always good to do surveys. And in this case, pick whichever is relevant to you. And that's that. Now we're in and we have access to Collab Pro. So that cost me about $15 Canadian. You can go ahead and cancel it right away. And usually they refund you the difference. So if you cancel it immediately, you'll get most of the charge back. Just as long as you're not using your 100 compute units. So we can go ahead and close those windows. We now have Collab Pro set up, so we should be ready to rock. We'll go back to our Notion page here. And if we're going to be using OpenAI's models, we should set up an OpenAI account. I am going to be demonstrating the OpenAI synthetic data generation here, so I do want to make sure I set up that account. So, of course, we'll head to platform.openai.com. And we're going to sign in. I'm going to use the handy single sign-on. So just choose my Generative AI demo email. They check me. We tell them about who we are. So I include my real name. I'm going to skip past my birthday, and we'll see you on the other side. You'll also need to verify your phone number. So this is an important step. If you don't do this, you can't have access to the API. I'm going to enter my phone number now, and I'll be back as soon as we're done. Okay, so now that we've set up our account, we've confirmed our phone number, we're good to start going. Now, if you've never set an account up before, then you'll have access to some free credits. Usually it's about $18 worth of credits. At least that's what it is in my local currency. If you don't have those, you will have to go to your account, manage account, billing, and then set up a paid account. So we can look at our usage page to determine how many free credits we have. As you can see, I don't have any free credits at all, so I'll have to set up some billing. I'm going to do that now and then come right back. All right, so now that we've got that set up, you can see we have this usage cap of $120, and we're ready to rock on the OpenAI front. And that concludes all of the setup that we need to do. So right now, basically we've set up Hugging Face, Colab, and OpenAI, and we're ready to rock. So let's head into the notebooks. First things first, we can find all the notebooks in the GitHub, all right here. Secondly, we can find the notebooks in this notebook section. I'm just going to go ahead and use that because it's a lot easier. So I'll click on this, and away we go. In this notebook, I'm going to click the runtime, change runtime type, and we're going to leave it at none. We don't need a GPU for synthetic data, so just make sure we don't risk it. We'll set it to none. I'm going to go ahead and pip install OpenAPI since we need to do that in order to use the library. While we're waiting for that to install, you can notice that I've put a link here that says follow these resources to create an API key. Let's go ahead and do that. So we can click on this link that says you can find your secret API key in your user settings. Since we don't have one yet, we will have to make sure we add one. We'll do that by clicking the Create New Security Key button. In order to not expose any sensitive information, I'm going to click this button and follow the prompts off screen. Now that I have my API key, I can paste it into the field that's asking for it here. Again, just to preserve privacy, I'm going to go ahead and do that, and then I'm going to remove it. So it's going to be stored in the environment variable, but we won't see it on the screen. Okay, so with our OpenAI API key set and Colab set up, we're good to go. We can load this prompter class. Now, I don't have access to GPT-4 on this newly created account. Haven't made it through the waitlist just yet. So I'm going to go ahead and I'm going to use GPT 3.5 Turbo to create our synthetic data. So I can just go ahead and copy and paste that into our prompter. Now I have these prompts. So I'm going to go ahead and set them up. Keep in mind that the role system is kind of like suggesting what the model should behave like. And then the role user is what we are querying it with. So in this case, we tell it it's a professional fashion designer, and I'm asking it to generate a Python list of 5 clothing items and their descriptions. So I'm going to go ahead and execute this prompt here. It gives us in this format, which contains exactly what we asked for. It also gave us this additional price column, which we don't need, but we have it, so why not? I'm going to go ahead and copy and paste this. Because I've actually had it return a Python list, you can see we can just run this cell and we have that in a list. You can do lots of tricky stuff here to shortcut that process, but due to the fact that especially GPT 3.5 Turbo is not always the best at following instructions the first time, we're just going to go ahead and use this kind of copy and paste method. You can have it spit out a list as long as you want. That's within the number of tokens it can output. So just keep that in mind. We're also going to have it generate ads for us. So we provide it with another prompt, and that prompt is, you are an ad executive. Your job is to create a short, punchy new ad for the following product. So we pass that along with all of the information we got from our previous prompt back to GPT, what is going to append that item by item to a list so that we can smush them all together later and create a data set. So let's run that prompt now. And as you can see, we get a number of absolutely fine prompts that will go with our descriptions and product names. Now we can move on to pip installing the Hugging Face hub. This is what's going to let us connect to Hugging Face, so it's very important. And this is what we're going to need that Hugging Face access token for that we created at the start of the video. Once we have this, we can go ahead and click our Hugging Face CLI login tool. I'm going to paste my security token in, and I will be back once that is done. We do not need to save this as a Git credential, so we can go ahead and hit N and then enter. And you can see that we have successfully logged into Hugging Face with that particular account. Now, all we're doing here is we're essentially creating a data set from our original prompts along with our additional add prompts. So all we have to do is run this create dataset function. Now this is going to include the price. So you could either delete it now or delete it later. It's totally up to you. For me, it's not a huge concern. Could even be interesting to try to include the price somewhere. So I'm going to go ahead and leave it there. Now we're going to use the datasets library. This is again from Hugging Face. We can go ahead and pip install that. And this is what's going to let us create the dataset that's compatible with Hugging Face Hub. And we can call some real straightforward commands on it. Once we've done that, we can go ahead and import dataset as well as load dataset. And then we're also, of course, everyone's favorite, load pandas as PD. Now we're going to leverage pandas to create a data frame from our data set, which right now, if we look at it, is just kind of this, list of objects. So we use pandas to turn it into a data frame, and then we use the from pandas method of dataset to create a dataset from the pandas data frame. We can look at it now and see that we have 5 rows and they have these columns. Fantastic. We're going to go ahead and put our Hugging Face username into this string. So for me, that was Generative AI Demo. And instead of naming it Cool New Dataset, we're going to go ahead and name it GenerAd AI Sample. We should be able to execute this line and see that it is indeed pushing this to the hub. If we want to look at it on the hub, we can navigate to Hugging Face. And we can see our data set right here. Perfect. That's exactly what we wanted. Now that we've created our synthetic data, we're good to move on to fine-tuning Bloom and deploying it with Hugging Face. Once we're into the Bloom collab, it's important to make sure that we're on the GPU runtime. The way that we do this is we click on runtime in the top middle of the screen here. We change runtime type. We're going to choose a GPU accelerator, and we want to choose premium. We can hit save. Now, if you want to look at the resources, first thing we'll need to do is connect to this. So click the connect button here in the top right. Now that it's connected, we can look at the resources we have access to. As you can see, because I'm on Colab Pro, I get access to 166 gigabytes of memory and 85 gigabytes of RAM, which is fantastic. Once we instantiate our GPU, we'll see how much VRAM we have. For now, though, we're just going to follow through the notebook. First thing we'll need to do is install our libraries. We can do that with these pip installs. We do need to make sure we're getting the most up-to-date version of the PEFT library as well as the transformer library. This is because these tools are relatively new, and so we want to make sure we have the most recent, least buggy versions of them. Okay, so now that that's completed installing, we can go ahead and move on to the next section. We're just going to load the Big Science Bloom 1B7 model. We have to set a few things up here because we do want to make sure that this works with our idea to train with the LoRa adapter. So we can go ahead and click play and just wait for the cell to complete. It's going to take a long time because it's a big model. The important things to look out for here is we want to see and make sure that we have the correct CUDA devices. So that's to tell our environment where our GPU is. And then we do want to also make sure we grab the tokenizer you just get from Hugging Face Hub. And while we're looking at this, you can also see now that we have a GPU locked in and we have 40 gigabytes of memory, that's going to be well enough to continue this process. While we're waiting for this to load, we can go ahead and head to Hugging Face. Just type in Bloom 1B7, and we get to look at exactly the model card for this model. So if you wanted to, say, plug in a different version of Bloom, so if we had to Big Science here, you can see they have a lot of different versions of Bloom. So if you wanted to plug in a different version, you could do that here, or you can just stay with the one we're on. This method should work for all sizes of Bloom, assuming that you can fit them into GPU memory. Now that it's done downloading the base model, we're going to go ahead and do a little bit of pre-processing for the layers. This is to make sure that everything is frozen. We don't want to actually train this model at all because we don't care to train it. We're training the adapter, and we're making a few adjustments to the precision of some of the layers just to ensure that we have the most stable training experience. Now this is just a handy little function, comes right from Hugging Face, that tells us how many parameters we're training versus the base model. So in this case, we're training less than 1% of the parameters we would train if we were training the actual model, and that's absolutely huge. One key thing here is that we are targeting a specific module. So the way that LoRa works is we're going to inject this trainable layer at key parts of our model. And in the case of Bloom, we want to inject that in that query key value layer. And if you are familiar with the paper attention is all you need, you know that query key value is an important part of the attention mechanism. Now we're good to move on. I'm going to use the sample dataset that I produced previously, though we could just plug and play the dataset we just created using our previous synthetic notebook. And I'm just going to do this because it's already got a lot of samples and it's already set up. So I'm going to go ahead and do that now. No matter what you named your columns or what you called specific things, all that matters here is that you're lining these kinds of things up with what you need. So while this notebook is set up to be for one particular project, it's rather plug and play when it comes to like the ability to change, fiddle with some things and make it work for your own use case. This is just going to print the data set showing us that we have X number of rows in each training and test set. And then it gives us an example of the first one. Nothing special here. We're going to create this definition for generate prompt, which is going to put our data into the format we want to teach our model. Again, we're teaching it structure, not data. So we want to teach it this kind of structure with the, product description and then add. We map that to the entire data set to ensure that all of our data is consistent with our goal. And then we're on to training. I'm going to go ahead and train this for way less steps because I've already trained this previously. But basically, all we need to do here is set up the training. We click the, after you change whatever you need to change or want to change, you can click the train button. A couple key things here. We want to make sure that this is false. So I wouldn't fiddle too much with that particular hyperparameter, but everything else you can fiddle around with. Just make sure that you have enough memory. So as you can see, while this is training, we're using about 7.7 gigabytes of our GPU's RAM, which is fantastic. And it didn't take very long to train because it was only training for 5 iterations. So not too much at all. Now, I'm going to go ahead and replace this username with my own username, which in this case was the Generative AI demo. I'm going to click enter here. Again, we want to log in with our notebook. So we're going to paste our token in it again. I do this off screen and I'll be back when it's done. Okay, and here we go. We log in and we are happy. We could just go ahead and push this model to hub using the push model to hub method of the model. Because we're using transformers, this whole process is incredibly straightforward. Now that we have it there, we can pull it back in and instantiate our model. This is going to again grab the base model since we did need the base model, though we didn't modify any of its parameters in order to train. Now that we have it loaded up, we get to take it for a spin. So we'll load the make inference function, which is going to let us put in a product name and a product description. So I'm going to put in Ruby slippers, and I'm going to describe them as beautiful slippers inlaid with sweet gemstones that look shiny and stuff. And then I'm going to use the make inference function we declared above, which is just going to do inference on this prompt. So as you can see, the quality of this example isn't very good because we are loading the one that was trained with only 5 examples. But it could be worse. And I mean, the idea here is that we just want to see the process. The data you choose, the amount you choose, everything else is totally up to you guys. So just keep that in mind. It also has these prompts that I included from the actual train of the model, or actual fine-tune in this case. So, it works pretty well. But we saw that in class, so I won't spend too much time on it here. Now that we have our model, though, the next step is deployment. So how do we deploy this? Well, number one, we can go back to Hugging Face, and we can check out our models. You can see that we have our model here. We can create a model card, and we can do our, pipeline tag to text generation. We can add whatever license we want. In the case of Bloom, we have to add the Big Science OpenRail -M license. You can fill out all of these to your heart's content. We can indicate which data set we use. So we use Generative AI Demo, GenerAd AI Sample. We can also add the library name. So in this case, we're using the adapter transformers. Go ahead and click on that. And we can hit commit to main, go back to our model card. Now at this exact moment in time, there is no inference API, so we can't do inference on the model card, but we can create a space and look at inference there. So we're going to do that. So I'm going to create a space in order to do this. So I'll just head over to our model here, and then I'm going to go to spaces. I'm going to confirm that I am a human and pass this sweet CAPTCHA, which is to complete the code. Now that we've got the CAPTCHA out of the way, we're going to create a new space. I'm going to call this demo. I'm going to use the Big Science. I'm going to use Gradio, and I'm going to select a NVIDIA T4 4V CPU, 15 gigabyte, 60 cents an hour space. Now, to create the space, we will need to provide billing information, since it is going to cost us 60 cents an hour to run this space. Since it is going to cost us 60 cents an hour to run this space, so I'm going to go ahead and do that now, off screen, and I'll return when it's done. Okay, now that we've done that, our space is here. This works just like a repository in GitHub, so you can kind of do whatever you'd like. I've already set up a sample app, so I'm just going to basically take that code and put it here. So basically, I'm going to go to FourthBrain AI, and we're going to go to the space for GenerAd AI. Currently, this is paused because, again, it costs 60 cents an hour to run it on GPU. I'm just going to go ahead and take the app.py. I'm going to full-on copy and paste it. And I'm going to take the requirements.txt and, again, just full-on copy and paste it. We'll head back to our space. We'll go to Files, create a new file called app.py, and I'm going to paste the code right into it. We have to change some stuff here, so I'm going to change this to Generative AI Demo / I believe we just called it GenerAd -AI. We can confirm that by going to our profile and looking at our model. We can also just copy this here, head back to our Python file, and boom, paste it in. As you can see, this is just running the inference right from the notebook, but we've added this very, very simple Gradio interface on top of it. It's the same code otherwise. So that's all we need to do. We have two text boxes, one called product name, one called product description, and then an output called add. Overall, very happy with that. I'm going to go ahead and commit this to main. Now, I'm also going to add our requirements. I'll do that by adding a file, creating a new file, calling this bad boy requirements.txt. And we are going to go ahead and paste in our requirements. Again, these requirements are right from the notebook. We're going to go ahead and commit to main, and then we can watch the logs go, everyone's favorite part. So I'll be back once the logs have completed running, and we have our space up and running. All right, so as you can see, the logs have finished, and we have this nice little space. Let's take it for a whirl. We'll try again with Ruby slippers, and these are some great Ruby slippers that look cool. We submit that, we let the GPU rip through it, and we see what output we get. There you go. So we get some repetition, and the prompt isn't amazing because, again, just train on 5 samples, but there you go. So that's kind of how we deployed it. If you run into any issues while it's setting up, Make sure that you have selected the NVIDIA T4 Small instance. That way you can ensure that you aren't running into any problems when it comes to having no GPU. You can set some different kind of settings here to make sure that it goes to sleep. And you can pause the instance to ensure that it's not charging you. So you can show it off just by clicking the on button. Just has to go through the build process again. But otherwise, you aren't being charged, which is the best. And that wraps us up. That's the whole process, kind of start to finish, including signing up for the different libraries, signing up for everything else we need. I hope this video helps. If you have any further questions, please don't hesitate to reach out to me via email, chris@fourthbrain.ai, or on Slack, Chris Alexiuk. You can find me. And I'd love to help you with whatever projects you're working on and get those awesome generative LLM-based ideas from kind of your notebook to deployment. So thanks so much for watching the video. I hope you enjoyed it, and we'll see you around. If you're interested in becoming part of FourthBrain's community, also please don't hesitate to reach out. We're always looking for people who are excited by AI, ML, and ML ops. So hope you have a great day. Thanks so much.